Hello students, Namaskar. In the previous video, we took some of the examples based on symmetric and skew symmetric matrices and the theorems we have studied. The example was to express a square matrix as a sum of a symmetric and a skew symmetric matrix. Let us take some more examples, students, and the example that I am taking is if A and B are two symmetric matrices, then prove that AB minus BA is a skew symmetric matrix. Dear students, the solution for this particular question or the proof for this particular question is, first of all, what we are given? We are given A and B as two symmetric matrices. So you can say A and B are two symmetric matrices. And it is given, students, it is given. Therefore, here you can put, since A and B are two symmetric matrices, therefore A is equal to A dash and B is equal to B dash. We can give them as equation number first and second. Now we have to prove that AB minus BA is a skew symmetric matrix. So here I am supposing let P is equal to AB minus BA. I have supposed the name of this entire matrix AB minus BA as P. Now what is our work? Our work is to prove P as skew symmetric matrix. And in order to prove P as a skew symmetric matrix, we need to find the transpose of P. So let us do that. The transpose of P is equal to AB minus BA, AB minus BA's transpose. Now the transpose of P is equal to, dear students, we know one property that we have studied of transpose of matrices. A plus B's transpose is equal to transpose of A plus transpose of B, and that may be for minus as well. Now transpose of AB minus BA is equal to transpose of AB minus transpose of BA. Okay. Now transpose of P is equal to transpose of AB is equal to transpose of B times transpose of A, and minus transpose of BA is equal to transpose of A times transpose of B. And here we have used the property that transpose of AB is equal to transpose of B times transpose of A. This is also one of the properties of transpose of matrix we have studied. Okay. So how transpose of AB has been written as transpose of B times transpose of A using this particular property. Now transpose of P is equal to transpose of B times transpose of A. In place of transpose of B we can write as B, and in place of transpose of A we can write as A from equation number first and second. So here I am writing B and then A minus AB, and this we have written from equation number first and second. Dear students, transpose of B is equal to B, transpose of A is equal to A, transpose of A is equal to A, transpose of B is equal to B, as A and B were two symmetric matrices. So from equation number first and second, we have put the values of transpose of A and transpose of B in this particular equation, and we have got this. Now this implies that transpose of P is equal to, we can take minus common, students, out of these two terms. So when we take minus common, here it is AB minus BA. Now transpose of P is equal to minus AB minus BA. AB minus BA is actually P, students. So this can be written as P. So what we have got, transpose of P is equal to minus of transpose of P is equal to minus of P, and by the definition of skew symmetric matrix. What is the definition of skew symmetric matrix? A square matrix A is said to be skew symmetric matrix if its transpose is equal to negative of it. Then here we have got the transpose of P as negative of the matrix P, and hence P is a skew symmetric matrix. That implies that P is a skew symmetric matrix. And when P is a skew symmetric matrix, what did we take the value of P? AB minus BA. That implies that AB minus BA is a skew symmetric matrix. And that is what we were to prove, hence proved. I hope you have understood it. The question was, if A and B are two symmetric matrices, then prove that AB minus BA is a skew symmetric matrix, and we have proved it. I hope you have understood. Taking one more example, students, that is based on multiplication of matrices. It is a very important kind of question. So let us get the example. If A is equal to 3, 4, minus 2, minus 2, and I is equal to an identity matrix of order 2, and also A square is equal to KA minus 2I, then find the value of K, scalar K, students. What is given? We are given a matrix A, and I is an identity matrix of the same order, and we are given an equation in terms of the matrix A, and we have to find the value of scalar K. So the solution for this particular question, students, will be, first of all, we will get all of the matrices included in this particular equation. So in this one, A, I, these two matrices are included, which we have. A square is, we do not have, so we can quickly find A square. So A square is equal to the matrix A, that is 3, 4, minus 2, minus 2, and multiply by 3, 4, minus 2, minus 2. Okay, now A squared is equal to, that will be also a square matrix of the same order 2. Let us get that. So 3 multiplied by 3 is equal to 9, and minus 2 multiplied by 4 is equal to minus 8. So it is 1 actually. Okay, now 3 multiplied by minus 2 is equal to minus 6, and plus 4. Minus 6 plus 4 is equal to minus 2. Now 12 minus 8. So it is 4. And now this row multiplied by this column, so minus 8 plus 4, that we have got minus 4. See, 4 multiplied by minus 2 is equal to minus 8, and minus 2 multiplied by minus 2 is equal to plus 4. So we have got minus 4. Now after we have got A square, students, will be putting the values of A, I and A square in the given equation. So let us do that. We have A squared is equal to Ka minus 2I, as it is given. After you have got the value of a square, now you can write, putting the values of a squared, a and I. Let us do that. We have the value of a square is equal to 1 4 minus 2 minus 4. So here I am putting the value of a squared, that is 1 4 minus 2 minus 4 is equal to k times matrix A, and matrix A we have 3 4 minus 2 minus 2 and minus 2 times the identity matrix, that is 1 0 0 1, implies that 1 minus 2 4 minus 4. This LHS is already simplified, students. Let us simplify RHS, and the simplest form of RHS is 3k. As a scalar is multiplied by a matrix, then each of the elements of the matrix will be multiplied by that particular scalar. So we have 3k and then minus 2. We have got it here, minus 2. Now this is minus 2 multiplied by k. So this is minus 2k and plus 0 or minus 0 you can say. So it is minus 2k only. Now 4k and minus 0, it will remain 4k only. And next one is minus 2k and that side it is minus 2 we have got. So we have got, students, the simplest form of RHS has this particular matrix and the simplest form of LHS has this particular matrix. We have got two matrices equal, students. So how can two matrices be equal? Two matrices are equal when their corresponding elements are equal. So the first element, this will be equal to this particular. We get 3k minus 2 is equal to 1. 3k minus 2 is equal to 1, and that can be written as 3k is equal to 3 and implies that k is equal to 1. We have got the value of k is equal to 1. Using one element we have got the value of k, and for the verification we can use the other elements as well. And when we use the other elements, the second element will be equal to this particular, means a1 2 will be equal to a1 2 here. So you can say minus 2k is equal to minus 2, minus 2k is equal to minus 2, and here as well k is equal to 1. Using the third one, 4k is equal to 4 implies that k is equal to 1, and the last one, minus 2k minus 2 is equal to minus 2k minus 2 is equal to minus 4. Here I am putting minus 4, and now this implies that minus 2k is equal to minus 2 goes that side, and it is plus 2, minus 4 plus 2 is equal to minus 2, and k is equal to 1. So using all four elements we are getting the value of k is equal to 1 only, and we can say the value of scalar k here is 1. I hope you have understood this particular question. This kind of question is important, students, from exams point of view. So I have taken this particular example to explain you. If any other question of this type is given, I hope you can surely do it. Thank you.